RICERCANDO encompasses a suite of tools for rapid exploration of Monroe data. Building an appropriate data representation is the main prerequisite for efficient data mining. We have developed scripts that systematically download the collected Monroe metadata and store them in a time series-based influx database. Our scripts create views of different time granularity to enable adaptable querying. Our key tools are based on Python, which allows fast prototyping and efficient data transformations through Pandas framework. Finally, we build functions that merge data coming from different sources, such as periodic and on-demand measurements, and expose them through easy-to-use structures. This is an example of getDF, a function that takes data from different tables, here ping, modem, and event tables are used, and merges them along the common time axis. Frequency parameter lets us select the desired granularity of the temporal data. This is crucial for fast interactive visualization that we're going to demonstrate later in this video. Interactive Geographical Data Visualization Notebook lets us examine measurement data on a map. We refer the notebook to an IP address where the database resides. We then select a particular measurement node and date, and the data is then shown on a separate map for each of the node's interfaces. Furthermore, the notebook lets us zoom and pan the maps, as well as select the dimension along which the data points will be colored. For instance, here different point colors correspond to different IDs of cells that a measurement device was connected to at the time of measurement. Finally, interesting data can be selected with the lasso tool and then saved to a separate Pandas data frame for further processing in Orange. Interactive Time Series Data Visualization Notebook lets us swiftly examine temporal data collected by Monroe platform. Again, we refer the notebook to an IP address of the database. We scroll down to the plot class instance. Here, we select the day, month, and year for which we will show the data, the ID of the desired measurement node, and the metric we would like to show on the y-axis. The data are shown on a separate graph for each of the node's interfaces. Vertical lines in the plots denote moments when external experiments were performed on the node. Just like with the GeoVisualization notebook, we are free to select the coloring dimension for the plotted data. Here, the color represents the received signal strength. What makes this visualization highly efficient is the automatic adaptation of the resolution according to the current zoom level. If we zoom further in, the notebook fetches fine-grained data from the database, though sampled with a second or sub-second granularity. Finally, hovering over a point shows additional dimensions corresponding to the data point. RICERCANDO nicely combines with Orange, a popular data mining tool. We developed a separate toolbox that lets users import Monroe data either directly from the database or via a pre-saved Pandas data frame. In case of the former, the user selects the node ID, dates, and the desired tables, and the data is ready for processing in Orange. Orange's wealth of options allows us to construct complex processing workflows. Here, we visually inspect the data and identify an anomaly. Why is RTT occasionally dropping below 100 milliseconds? To inspect this, we construct a new feature. As seen in this graph, all low RTT points are now colored red. Finally, the significant groups widget we have developed performs the hypergeometric test to find the most characteristic feature of our anomaly. It turns out that low RTT periods coincide with times when experiments are active. RICERCANDO does more than we can show in a short video. For instance, besides geographical and interactive time series data visualization, we have also implemented a notebook for anomaly detection. All the RICERCANDO tools are released as open source software on GitHub. To install RICERCANDO, first install prerequisites, such as Orange, Pandas, and others. We suggest using Conda for this. Then, you can install the RICERCANDO module using pip. Start Jupyter Notebook Server and open one of the pre-made notebooks. Or open Orange and access Monroe data from there. We wish you successful mining.